Bismillahirrahmanirrahim. Assalamu alaikum. Today I will solve the A-level past paper 1, May-June 2023. Let's start the paper. Question number 1. The equation of a curve is such that dy over dx equal to 4 over x minus 3 power 3 4x greater than 3. The curve passes through the point 4, 5. Find the equation of the curve. Now you see here dy over dx equal to 4 over x minus 3 power minus 3. Now we write it as dy over dx will be equal to 4 into x minus 3 power minus 3. Now we shift the dx from left to right side. We get dy equal to 4 into x minus 3 power minus 3 dx. Now to find the equation of the curve, we take the integration on both sides. Now we write it as integration of dy equal to integration of 4 into x minus 3 power minus 3 dx. Now integration of dy will be equal to y, and the 4 is written as it is. Now the integration of x minus 3 power 3, we use the formula x power x minus a power n. Integration of this expression equal to x minus a power n plus 1 over n plus 1. Now we write it as x minus 3 power minus 3 plus 1 over minus 3 plus 1 plus e. Now we can write it as y equal to 4 into x minus 3 power minus 2 divided by minus 2 plus c. Now we write it as minus 2 into x minus 3 power minus 2 plus c. Now to find the value of c, we substitute the value 4, 5 in this equation because the curve passes through the point 4, 5. 4, 5, y equal to 5 and minus 2 is written as it is 4 minus 3 power minus 2 plus c. We get minus 2 into 1 power minus 2 plus c, and 5 equal to minus 2 plus c, and c will be equal to 7. The equation of the curve become y equal to minus 2 into x minus 3 power minus 2 plus 7. This is the answer. Question number 2, the coefficient of x4 in the expansion x plus a power 6 is p. The coefficient of x square in the expansion of a x plus 3 power 4 is q. Find p plus q. It is given that p plus q equal to 276. Find the possible values of a. You see here the first expression here is x plus a power 6. Now find the coefficient of x4 of this expansion. We use the formula for a plus b power n. The n term value equal to the rth term value will be equal to tr plus 1 equal to ncr into a power n minus r into b power r. Now we use this formula to find the coefficient of x4. We write it here as 6cr into a is the first term, that is x, into x power n minus r, n is 6, 6 minus r, into b is a power r. Now you see here we have to find the coefficient of x power 4. Therefore that x become x 4 power 4 equal to x power 6 minus r. Therefore we write as 4 equal to 6 minus r. Therefore the r will be equal to 6 minus 4, and that is r will be equal to 2. Therefore we write it as t power t 2 plus 1 is 3 equal to n is 6, cr is 2 into x power 4 into a power 2. Now 6c2 is equal to 15 and a square is written as it is, x4 is written as it is. The coefficient of x4 will be 15a square. Now we find the coefficient of x square for the expansion ax plus 3 power 4. Now we write here is ax plus 3 power 4. The coefficient of x square, we use the same formula here for the expansion a plus b power n. Here is tr plus 1 equal to ncr into a power n minus r b power r. Now you see here, and the first term is ax. Now we write it as ncr, n is 4. Now we write 4cr. A power a first term is ax. Now we write it as ax power 4 minus r into b is here is 3. Now we write as 3 power r a power 4 minus r into x power 4 minus r. Into 3 power r and 4 cr is written as it is. Now we write it here x power 4 minus r, that is equal to, this is equal to x square. Now that we write x square, therefore 2 equal to 4 minus r, then r will be equal to 4 minus 2 and r will be equal to 3. Now we put the value in this formula 4cr, we write it as 4c2 into a power 4 minus 2 into x square, because x power 4 minus r is x square, into 3 power r. Now the 3 power r is 2, we write as here is 3 power 2, 4c2 is equal to 6, a power 4 minus 2 is a square, 3 power 2 is 9 and h square, and that value is 9 times 6 is 54 a square into x square. Therefore 54 a square is the coefficient of x square. Now you see here p plus q equals to 276. Now the coefficient of p x4 is p, we write it as 15a square. The coefficient of x square is q, we write it as 54a square. Now p plus q will be equal to 276 and 15a square plus 54q square a square will be equal to 276 and 54 plus 15 is 69 a square equal to 276. Then a square will be 276 divided by 69. That's equal to 4. A square equal to 4. Then a will be equal to plus minus 2. These are the possible values of a. Now question number 3, part A, express 4x square minus 24x plus b in the form of a into x plus b power 2 plus c. A, b, c are the integers. Now to find c is to be given in terms of the constant p. Now we have to convert this expression in this form. Now we write this expression 4x square minus 24x plus p. Now we take the common. Here is 4 is a common, that become x square minus 6 plus p, 6x plus p. Now we can write it as 4 into x square minus 2 times of x into 3, we can write it as 6x is minus 2 into x into 3. If we add plus 3 whole square in this expression and minus 3 whole square in this expression to make these two terms into a complete square expression. Now we write it here plus 3 square minus 3 square and plus p is written as it is. Now we write it as 4 into x square minus 2 into x into 3 plus 3 square minus 4 into 9 plus p. Now we can write it as 4 into x minus 3 whole square plus p minus 36. Now here is c equal to, we have to find c. And the here a is equal to 4, b equal to minus 3, and c is equal to p minus 36. This is the answer. The part B, hence or otherwise find the set of values of p for which 4x square minus 24x plus p has no real root. Now you see here, this is the quadratic equation. In the quadratic equation, the no real root b square minus 4ac is less than 0. Therefore, we write it as b here is 20 minus 24. We write minus 24 whole square. 4 into a is 4, and c we write as this c is p is less than 0. We can write it as 24 into 24 minus 16p is less than 0, and we shift the 16p from left to right side. 16p is greater than 24 over 24, and p will be greater than 24 over 24 over 16. Now therefore we get p is greater than 36. Therefore the value start from onward to 36 to infinity. This is the answer. Number 4, solve the equation 8 into x power 6 plus 215 x power 3 minus 27. We can write it as 8 into x cubed into 2 plus 215 x power 3 minus 27 equal to 0. We substitute t equal to x power 3. Therefore, this equation becomes 8t squared plus 215t minus 27 equal to 0. This is the quadratic equation, and we can solve this quadratic equation by midterm breaking rule. In this midterm breaking, we factorize this left hand side expression. Firstly, we multiply 8 multiplied 27, we get 216. To make a factor 216 in such a way, when we add these two numbers, we get 215 and multiply, we get 216. You see here 216 times 1 is 216. When you add plus 216 and minus 1, we get 215. Now we can write it as 8t squared plus 216t minus t minus 27 equal to 0. Now 8t is taken as a common. We get t plus 8 times 2 is 16, and 5 is as a carry, so that value becomes 56. 8 times 7 is 56. Minus t minus 27, we get 1 is taken as a common. We get t plus 27 equal to 0. Therefore, we can write it as t plus 27 into 8t minus 1 equal to 0. Therefore, we can write it as either t plus 27 equal to 0 or 8t plus minus 1 equal to 0. Therefore, t equal to minus 27 and 8t equal to 1. The t equal to 1 over 8. Now, the value of t is x cubed. Therefore, x cubed equal to minus 27. We can write it as minus 3 whole cube in equal to x cubed. Therefore, x will be equal to minus 3. And same here is x power 3 equal to 1 over 2 power 3. And therefore, x will be equal to 1 over 2. And therefore, the solution of this equation will be x equal to minus 3 and x equal to 1 over 2. And this is the answer. Question number 5. The diagram shows the curve with the equation y equal to 10 into x power 1 over 2 minus 5 over 2 into x power 3 over 2. The curve meets the x-axis at point 0, 0 and 4, 0. You see here we have to find the area of this shaded region. This area of shaded region, it is the area between the curve and the x-axis. The area of shaded region between curve and x-axis, the formula is AB into f of x dx. We can write it as AB y dx. And you see here A and B are the point where the curve intersects the x-axis. The curve intersects the x-axis at x equal to 0 and x equal to 4. Therefore, we write it as 0, 4. And you see here y is 10x power 1 over 2 minus 5 over 2 into x power 3 over 2 into dx. And now we take the integration of this equation of the curve. The integration of 10 into x power 1 over 2, we write 10 is written as it is. And x power 1 over 2 integration is x power 1 over 2 plus 1 divided by 1 over 2 plus 1. And minus 5 over 2 is written as it is. And integration of x power 3 over 2, we take x power 3 over 2 plus 1 and we divide this expression with the power 3 over 2 plus 1. Now we apply the limit here 0 to 4 and after this now we simplify it. We can write it as 10 into x power 3 over 2 over 1 over 2 plus 1 is 3 over 2 and same here is minus 5 over 2 into x power 5 over 2 over 5 over 2 and we can write it as here's 10 in and apply the limit also here 0 to 4 and next is 10 into 3 over 2 we can write it as 2 over 3 into x power 3 over 2 minus 5 over 2 into 5 over 2 shift from denominator to numerator that becomes 2 over 5 and x power 5 over 2. Now we applied the limit 0 to 4. We can write it as 20 over 3 into x. We can write x power 3 over 2x into square root of x. 2 times 1 is 2, 2 times 1 is 2, 5 will be cancelled. We get 1 into x power 5 over 2. X power 5 over 2, we can write x square into x power 1 over 2. And therefore, we write x square into square root of x and apply the limit 0 to 4. Now, firstly, we put the upper limit in this expression. We get 20 over 3 into 4 and square root of 4 minus 4 square into square root of 4 minus, and we substitute the lower limit value 20 over 3 into 0 minus 1 into 0. Now this value becomes 20 into our 3 multiplied by 4 into 2 is 8 minus 16 into 2 minus 0 and that's equal to 160 over 3 minus 32 over 1 and therefore that value will be equal to 160 minus 96 and that's equal to 64 over 3 and this is the area of the shaded region, and this is the answer. Question number 6. The diagram shows a sector OAB of circle with center O. Angle AOB is theta radian, OB equal to AP equal to X. Show that the arc length AB is 2x theta cos theta. Now the formula of the arc length AB equal to theta over 2 pi into 2 pi r. Now you see here, we can write it as theta into r. R is the radius. You see here, OA is the radius. Now we write theta into OA. Now firstly we find the length OA. How can we find? You see here, this is the isosceles triangle because AP and OP lengths are equal, and therefore the base length OA having the same angle. This is theta radian, this is also theta. Now the angle between OPA will be equal to theta plus OPA equal to 180. Therefore, we write it as 2 pi, but because the angle is in radian, now therefore angle OPA will be equal to 2 pi minus 2 theta. We write it here as theta plus OPA equal to pi, and therefore OPA equal to pi minus 2 theta, because sum of interior angle of triangle equal to pi, and therefore we write it as OPA pi minus 2 theta. We put the value here, pi minus 2 theta. Now we can find the length OA by using cosine rule. Therefore, OA length will be equal to OA square equal to OP square plus PA square plus 2 into OP into OA into cos of angle between them pi minus 2 theta. Now this is the negative sign. Now we put the value OA square will be equal to OP length is x square and PA length is also x square minus 2 into OP length is x into cos of pi minus 2 theta. Now that's equal to 2x square minus 2x square and pi minus 2 theta, cos pi minus 2 theta. You know, cos pi minus theta equal to negative cos theta. Therefore, we write here is negative cos theta. Here is the, you see here, cos pi minus theta is cos theta. Therefore, cos pi minus 2 theta will be equal to cos 2 theta. And now we simplify this, 2x square minus minus plus 2x square cos 2 theta and 2a square, and therefore we write here is 2x square is taken as a common. Therefore we write 2 plus 2 cos theta, and we take the square root on both sides. We get OA square is OA, and we take this value x square root is x into square root of 2 into 1 plus cos 2 theta. Now we can write it as square root of 2 into x into 1 plus cos 2 theta square root. Now the formula of half angle, you can see from the formula sheet that the cos 2 theta cos theta equal to 1 plus cos 2 theta over 2 square root, and you can write it as cos under root 2 cos theta is equal to 1 plus cos 2 theta square root. Now we apply this formula here. We can write it as under root 2 into x into under root 2 into cos theta, and square root of 2 into square root of 2, we get 2 into x into cos theta. Therefore, the radius is OA is 2 into x cos theta. We put the value there. Now the value becomes theta into 2 into x cos theta, and that's equal to 2x theta into cos theta, and we have to prove the arc length is AB is equal to 2x theta cos theta. This is the answer. First part B, find the area of shaded region APB in terms of x and theta. The area of this shaded region will be equal to area of sector minus area of triangle. Area of sector OAB minus area of triangle OPB. This is the triangle OPA. Now you see here the area of sector will be equal to 1 over 2 r square theta, and you see here this radius of this sector is OA. We write OA square into theta, and area of triangle will be equal to 1 over 2 OP into PA sine pi minus 2 theta. Now you see here 1 over 2 OA length is 2x cos theta whole square into theta minus 1 over 2 OP is x, PA is also x, multiply sine pi minus 2 theta. We can write sine 2 theta, and because sine pi minus theta equal to sine theta, therefore we write it as sine pi minus 2 theta equal to sine 2 theta. Now we can write it as 1 over 2 4x square cos square theta minus 1 over 2 x square. Now sine 2 theta, the formula of sine 2 theta from the formula sheet, we can see the formula is sine 2 theta is 2 sine theta cos theta. Therefore, we write here is 2 sine theta cos theta, and 2 will be cancelled, and 2 times 2 is 2. 2 times 2 is 4, and therefore we get 2x square cos square theta minus x square sine theta into cos theta. Now we take the common. Now therefore you see here x square and cos theta is taken as a common. The 2x as 2 into cos theta minus x square is common, cos theta is common, 2 cos theta minus sine theta, and this is the answer. Question number 7, part A. By first expanding cos theta plus sine theta whole square, find the 3 solution of the equation cos theta plus sine theta whole square equal to 1. Now, firstly, we write here is cos theta plus sine theta whole square, that's equal to cos square theta plus sine square theta plus 2 sine theta cos theta. We use the identity a plus b whole square, that's a square plus b square plus 2ab. Now y1 is written as it is. Now you can write it as cos square theta plus sine square theta equal to 1, and 1 plus 2 sine theta cos theta equal to 1. Therefore 2 sine theta cos theta equal to 1 minus 1 is 0, and 2 sine theta cos theta, we write it as sine 2 theta equal to 0. Now 2 theta will be equal to sine inverse 0. You know the sine inverse 0 2 theta equal to 0 or 2 theta equal to pi or 2 theta equal to 2 pi. Therefore, the theta will be equal to 0 over 2 is 0. Here is theta equal to pi over 2 and here is theta equal to pi, and the solution 0, pi over 2, pi, and this is the answer. Part second, hence verify that only solution of the equation cos theta plus sin theta equal to 1 for 0 to pi are 0 and pi over 2. Now you see here the solutions of these equations are theta equal to 0, theta equal to pi over 2, or theta equal to pi. Firstly, we put 0 in this equation, that cos 0 plus sin 0, cos 0 is 1, 1 plus 0 equal to 1, therefore 1 equal to 1, and this is the possible values, theta equal to 0. And next we check here is cos pi over 2 plus sin pi over 2 equal to 1. You see here cos pi over 2 is 0 and sin pi over 2 is 1 and 1 equal to 1, and this is also theta equal to pi over 2 is the solution. Now we see that we put the value theta equal to pi in this equation, that cos pi plus sin pi equal to 1, cos pi is minus 1, sin pi is 0, then minus 1 does not equal to 1. Therefore, theta equal to pi is not a solution. Therefore, only two solutions we have, theta equal to 0 and pi over 2. This is the answer. Question 7 part B, prove the identity. Firstly, we take the left hand side of this identity to prove it. Now you see here the identity is sin theta over cos theta plus sin theta, and 1 minus cos theta over cos theta minus sin theta. Now to make the denominator same, we write it as here cos theta plus sin theta into cos theta minus sin theta, and we can write here when we divide this expression by cos theta plus sin theta, we get cos theta minus sin theta. We multiply to sin theta, that is sin theta into cos theta minus sin theta. And same here is plus, divide this expression by cos theta minus sin theta, we get cos theta plus sin theta. Therefore, we write 1 minus cos theta multiplied by this expression cos theta plus sin theta. Now you see here, we simplify it, and to simplify this, we get sin theta cos theta minus sin squared theta, and 1 into cos theta is cos theta, 1 into sin theta is sin theta, minus cos squared theta, minus plus minus sin theta cos theta, and over cos theta plus sin theta into cos theta minus sin theta, we can write a square minus b square, cos square theta minus sin square theta, and same here is cos theta plus sin theta cos theta, and minus sin theta cos theta will be cancelled, and we can write sin theta plus cos theta minus sin square theta plus cos square theta. We combine these two values, and therefore we can write it as cos square theta minus sin square theta is equal to 1 minus 2 sine square theta, and this is the formula. Cos square theta minus sin square theta equal to 1 minus 2 sine square theta. Theta plus cos square theta equal to 1 is the identity here, and we write it as 1 minus 2 sine square theta, and this is the right hand side we have to put. Question number 7, part C, is using the result of part A and part B, solve the equation. In this equation, the left hand side you see here in the part B is equal to cos theta plus sin theta minus 1 over 1 minus 2 sine square theta. Therefore, we write this value cos theta plus sin theta minus 1 against the left hand side. Now we write cos theta plus sin theta minus 1 over 1 minus 2 sine square theta. And right hand side we write here as it is 2 into cos theta plus sin theta minus 1. And we shift the right value from right to left side. Now cos theta plus sin theta minus 1 over 1 minus 2 sine square theta minus 2 into cos theta plus sin theta minus 1 equal to 0. Now we take the common cos theta plus sin theta minus 1, and we get 1 over 1 minus 2 sine square theta minus 2, and that is equal to 0. Now we get two factors. One is cos theta plus sin theta minus 1 equal to 0, or 1 over minus 2 sine square theta minus 2 equal to 0. We shift the value minus 2 from left to right side. We get 1 minus 2 sine square theta equal to 2. Now we simplify this cos theta plus sin theta equal to 1, and we get two values. Theta is equal to 0 or pi over 2. For against this, you see here, this is the, we already verify in the part A of second part. In this, a value of theta is 0 or pi over 2. Therefore, we write is 0 and pi over 2. Now we find this value 2 equal to 1 over 1 minus 2 sine square theta, and that will be equal to 2 minus 4 sine square theta equal to 1. Now we can write it as minus 4 sine square theta equal to 1 over 2 and 1 minus 2, and that will be equal to minus 1, and minus 4 sine square theta equal to minus 1, minus will be cancelled. Therefore, sine square theta equal to 1 over 4, then sine theta equal to plus minus 1 over 2, and for the acute angle value, alpha will be equal to sine inverse 1 over 2, and this alpha will be equal to pi over 6. The value of theta in the range of 0 to pi, therefore the value lie in first and second quadrant, and in the first quadrant theta will be equal to alpha, and in the first quadrant theta will be equal to alpha, and in the second quadrant theta equal to pi minus alpha. Therefore the value will be theta equal to pi minus pi over 6 and theta equal to alpha. Therefore we write it as pi over 6, and this value is pi minus pi over 6 equal to 5 pi over 6, and therefore the possible values of theta will be 0, pi over 2, and 5 pi over 6, and pi over 6. This is the answer. Question number 8, the diagram shows the graph of y equal to f of x where function is defined here. Part A, on the diagram above, sketch the graph y equal to f inverse of x. Now you see here, this is the graph of f of x, and this graph f of x, we have to take the inverse graph of this graph. Now, to find the inverse graph, firstly we will draw a line y equal to f of x. Now we will draw the line y equal to f of x. Now we take 2 points to draw the lines. Pi over 2, x is pi over 2, y is also pi over 2, x is pi, y is pi, and this is the line y equal to f of x, and the inverse graph is the reflection of the f of x across the line y equal to f of x. Now to mark the reflection points, you see here, this is the point. We will mark the points from this line. We take the point on opposite side or with the same distance. Now this points will be, now you see here, we can get this point, and this is the point, reflection point, and same here is the reflection point. We take other points. Now you see here, we take the distance, this distance from line to that curve, and we take the same distance on opposite side from this line to this position. This is the second point, and we join these points and draw the curve, and this is the curve, and this curve shows the graph y equal to f inverse of x. And next is the find the expression f inverse of x. Now you see here, f of x equal to 3 plus 2 into sine 1 over 4 x. Now we can write f of x equal to y, and yx will be equal to f inverse of y. Therefore, we can write it as y equal to 3 plus 2 sine 1 over 4x. To find the inverse function, we make the subject x. Now you see here, we can write it as y minus 3 equal to 2 sine 1 over 4x, and that will be equal to y minus 3 over 2 sine 1 over 4x, and this value can be written as sine inverse y minus 3 over 2 equal to 1 over 4x, and therefore x will be equal to 4 into sine inverse y minus 3 over 2, and x equal to f inverse of y, and that's 4. This is equal to 4 into sine inverse y minus 3 over 2. We replace the y by x. We can write it as f inverse of x equal to 4 into sine inverse x minus 3 over 2, and this is the inverse expression. Now move the next part of this question. Part C, the diagram above shows the part of the graph of the function for g of x equal to 3 plus 2 into sine 1 over 4x. 4x is greater than equal to minus 2x and less than equal to 2 pi. Sketch the graph on the diagram above and explain whether the function g of x has an inverse. Now, firstly, we complete the graph because this graph here is 0 to 2 pi. Now we draw the graph 0 to minus 2 pi. To draw this graph, we take some values of x here. For x equal to minus pi over 2, and then x equal to minus pi, and x equal to minus 3 over 2 pi, and x equal to minus 2 pi. We find the value of g of x against these value. Now we calculate it. Now you see here for x equal to minus pi over 2, the value of y is 2.2. For x equal to minus pi, the value is equal to 1.58. Same here is x equal to minus 3 pi over 2, the value of y become 1.15. You can calculate this value by substituting the value of x in this formula. And same here, x equal to minus 2 pi, the value of y is 1. Now we mark the value in terms of numbers. You see here this pi over 2 mean 1.57, pi means 3.142, and therefore the pi over that is pi over 2, and this value is pi over 4. When you divide 3.142 divided by 4, we get 0.79. And same here, you see here the one square, small square is 0.79, next is 1.57, and next square 2.35. Now we mark the value minus pi over 2. You see here the answer of y is 2.2. Now this is 2.3, therefore just below the 2.3, and this point will be here, and this is 2.2. And same here is when x equal to minus pi, you see here the answer is 1.58. This is 1.57, that is just above the 1.57, that is 1.58. And next is minus 3 pi over 2. You see here the value of y is 1.15. We mark the point 1.15. This is the middle of the 0.79 to 1.57. This is 1.15. And we mark this minus 3 pi over 2, and y is 1.15. And this is the point. And same, next is the minus 2 pi, y equal to 1. Now we join these points and we get the graph. Now you see here function is an increasing function, therefore the inverse function is possible. So we will write it as inverse because it is one-to-one function, because it is one-to-one function. And we will check one-to-one function by draw the horizontal line. When you draw the horizontal line, the horizontal line will pass only the one point of the graph. Horizontal line test, the line passes the graph only one point. Now next move the next part of this question. Part D describes fully sequence of 3 transformation that can be combined to transform y equal to sine of x and the graph y equal to f of x, making in order to clear in which the transformation applied. Now you see here y equal to sine x, then we can write f of x equal to sine x. Now you see here g of x equal to 3 plus 2 sine 1 over 4x. Now we can find this function. If we multiply x by 1 over 4, we get sine 1 over 4x. And this is the first transformation. And this in the second transformation, we multiply the 2 into 1 over 4x. We get 2 into sine 1 over 4x. And in the third transformation, we add the value in this function. We get 3 plus 2 into f of 1 over 4x. We can write it as 3 plus 2 into sine 1 over 4x. Now you see here are 3 transformations. In the first transformation, the function inside multiply by 1 over 4. When you multiply the function inside or outside, it is stretching. And when any change inside, it is along the x-axis transformation, therefore stretching along x-axis. And the scale factor here is multiply 1 over 4, the value of x is. When any transformation inside, we take the opposite of this value. Now you see here it is multiply 1 over 4. We will take, therefore we factor is 4. And in the next transformation, you see here this function is multiplied by 2. When you multiply the function, the transformation is stretching. We write here is stretching. But if the multiplication outside the function, therefore the stretching along the y-axis, and the scale factor is taken remain as same. When you any change outside this, you see here it is multiplied by 2, the factor is 2. And the last is third transformation. You see here 3 plus 2 f of 1 over 4x. Here the function 3 is added in this function. Therefore this transformation will be when you add something, it is the translation, and the change outside the function, therefore its translation along y-axis. Now we can write it as 0, 3. It means the function transform 3 unit upward, and these are the 3 transformation from which function f of x transform into g of x. This is the answer. Question 9. The second term of geometric progression is 16. The sum of infinity is 100. Find the 2 possible values of first term. Now, firstly, you see here second term we write is here is t2, and that is equal to 16, and the sum of infinity is equal to 100. And the geometric progression, we suppose that a r not in AR1 into AR square, and this is the geometric progression. In this geometric progression, AR is the second term, that will be equal to 16. Therefore, we can write it as R will be equal to 16 over A. Here is S infinity. The formula is A over 1 minus R equal to 100. And we multiply 1 minus r by 100, we get 100 into 1 minus r equal to a, and that's equal to 100 minus 100r equal to a, and this 100r will be equal to 100 minus a. The r will be equal to 100 minus a over 100, and we can compare these two r values. That's r will be equal to 16 over a, and this r is 100 minus a over 100, and we can write it as 1600 equal to 100 a minus a square, and we shift the value from right to left side. We get a square minus 100a plus 1600. Now we can solve this equation by using the midterm breaking rule. In the factorization, we take the factor of 1600. When you add, we get 100a. Now 18 times 20 is 1600, and therefore the factor, we can break the 100a by writing minus 8a minus 20a, and plus 1600 is written as it is. Now we take the common, a minus 80 it becomes, and that's 20 is taken as a common, a minus 80 equal to 0. That a minus 80 into a minus 20 will be the factor. We can write either a minus 80 equal to 0 and a minus 20 equal to 0. Therefore, the values of a will be equal to 80 and a will be equal to 20. There are two values of a, and this is the answer. Part B, show that n term of one of two possible geometric progression is equal to 4 power n minus 2 multiplied by n term of the other geometric progression. Now we already find the value of a is equal to 20 and a equal to 80, and you already know the AR is equal to 16. Now we write it here. R will be equal to 16 over A, and that is equal to 16 over 80, and 16 times 1 is 16, 16 times 5 is 80. The value of R equal to 1 over 5, and same here is the value of R. Here is AR equal to 16 and A is 20, therefore R will be 20R will be equal to 16, R will be equal to 16 over 20, and that R will be equal to 4 for the 16, 4 times 5 is 20, 4 over 5. Now the inner term value of this expression will be, we write here is T n, that will be equal to AR n minus 1, and that is A here is 80 and R here is 1 over 5 power n minus 1, and same here is that is first value of nth term of the geometry. We find the nth term of second sequence. Tn will be equal to AR n minus 1. Now we get A is 20, 16, 20, and R is 4 over 5 power n minus 1. We can write it as 20 into 4 power n into 1 over 5 power n minus 1. Now that is T dash n. Now the first sequence, one sequence is equal to product or multiplied by a term of other geometric sequence. Therefore, we can write it as T dash n will be equal to 4 power n minus 2 multiplied by Tn. Now we proved here T dash n over Tn equal to 4 power n minus 2. T dash n over Tn ratio will be equal to T dash n is 20 into 4 power n into 1 over 5 power n minus 1. And next is the 80 into 1 over 5 power n minus 1. 20 into 4 n minus 1 and into 1 over 5 power n minus 1, 80 into 1 power n minus 1. This value will be divided. Now 20 times 4 is 80. We can write 1 over 4 into 4 minus 1. That value becomes 4 power n minus 1 into 4 power 1 minus 1. That's equal to 4 power n minus 2. And that's equal to right hand side. And this left hand side will be equal to right hand side, and it is the proof. Question number 10, the equation of circle is x minus a whole square plus y minus 3 whole square equal to 20. The line y equal to 1 over 2x plus 6 is a tangent to circle at point P. Show that one value is 4 other, find the other possible values. Firstly, we write the equation of circle x minus a whole square plus y minus 3 whole square equal to 20. The line is a tangent to the circle. This is the tangent line, 1 over 2x plus 6. Therefore, this y will be equal to 1 over 2x plus 6. We put the value in this equation. We get x minus a whole square plus 1 over 2x plus 6 minus 3 whole square equal to 20. This now we expand x minus whole square by using identity a square minus 2ab plus b square. That's become x square minus 2ax plus a square, and that's also 1 over 2x plus 3 whole square equal to 20. We can write it as x square minus 2ax plus a square, and plus we using the identity a plus b whole square. That's when that's equal to 1 over 4x square plus 2 times of ab become 2 into 1 over 2 into x plus into 3 plus 3 square equal to 20. Now this value become x square minus 2ax plus a square plus 1 over 4 x square plus 3x plus 9 equal to 20. Now we get x square minus 2ax plus a square plus 1 over 4x square plus 3x minus 11 equal to 0. Now we multiply by 4, we get 4x square minus 8ax plus 4a square plus x square plus 12x minus 44 equal to 0. Now we can write it as 5x square plus minus 8a plus 12 into x. We take a common x. Next is plus 4a square minus 44 equal to 0. Now this line 1 over 2x plus c is tangent to the circle. Therefore, the discriminant for value of a will be equal to 0. T square minus 4ac will be equal to 0 to find the value of a. Now we put the value of b here is minus 8a plus 12 whole square minus 4 into a is 5 and c is 4a square minus 44 equal to 0. We take a common 4 square, we get minus 2a plus 3 whole square minus 4 into 5 and 4 is taken as a common a minus 11 a square minus 11 and 16 is a common, we get minus 2a plus 3 whole square minus 5 into a square minus 11 equal to 0. Now 2a square plus 3 we can write it as 4a minus b whole square identity, that's equal to 4a square plus 9 minus 2 into ab 2 into 2a into 3 minus 5a square minus 55 equal to 0. Now we can write it as 4a square minus 5a square minus a square minus 12a plus 64 equal to 0. Now we divide by minus 1, we get a square plus 12a minus 64 equal to 0. Now we take the factor of 64. Now 16 times 4 is 64. Therefore, by using midterm breaking method, we factorize this expression. A square plus 16a minus 4a minus 64 equal to 0. Now we take the common a plus 16, a 16 minus 4 is common, a plus 16, and therefore we get a plus 16 into a minus 4 equal to 0. Therefore, two values of a is equal to 4 or a equal to minus 16, and this is the answer. Part B, for a equal to 4, find the equation of normal to the circle at P. Now the point P here is, this is the point and this is the tangent line at point P. The normal to the tangent line, it is the line which passes through the center of the circle. Now this is the equation of the circle where a is equal to 4. In this, according to this equation, the center will be 4. The gradient of the normal line CP will be equal to y minus 3 over x minus 4. That is the gradient. Now this is the tangent line and the gradient of this tangent line is 1 over 2. The gradient of the normal line will be minus 2. Therefore, we can write it as m is considered as 2 and y minus 3 over x minus 4 equal to minus 2. We can write it as y minus 3 equal to minus 2 into x minus 4. Therefore, y minus 3 equal to minus 2x plus 8, and this is equation y equal to minus 2x plus 8 plus 3 plus 11, and this is the answer. Part C, 4a equal to 4. Find the equation of two tangents to the circle which are parallel to the normal found in B. You see here, this is the tangents T1 and T2 which are parallel to the normal found in B. This is the normal line. We name it as PQ, and this normal line having the equation y equal to minus 2x plus 11, we name the equation of QP line, and this line and the two tangents are parallel to this normal line. T1 is parallel to QP and T2 is also parallel to QP. Now to find these two equations of line, firstly we have equation of diameter, and this is the diameter AB. Now the equation of diameter AB will be equal to y minus y1. This is the point where the diameter pass into m into x minus y minus 3 in equal to m into x minus 4. Now the gradient of this normal will be m dash, we name it as m dash, will be equal to gradient of this line QP. Now gradient of this line is minus 2, therefore that will be equal to minus 1 over minus 2, that's equal to 1 over 2. Now the equation of this diameter will equal to 1 over 2 into x minus 4. Now we write this equation of diameter, and y minus 3 equal to 1 over 2x minus 2, and we multiplied by 2, 2y minus 6 equal to x minus 4, and 2y minus 2y will be equal to, now y will be equal to 1 over 2x plus 1, and this is the equation of diameter, and this diameter equation passes through the tangents points A and B. Now we put the value of this equation of tangent in the circle, equation of circle. The equation of circle here is x minus 3 whole square plus x minus 4 whole square plus y minus 3 whole square equal to 20. We put the value here, x minus 4 whole square plus y is 1 over 2x plus 1 minus 3 whole square equal to 20. Now we get x minus 4 whole square plus 1 over 2 x minus 2 whole square equal to 20. Now we simplify this equation, we get x square minus 8x plus 16, and that's equal to 1 over 4x square plus 4 minus 2 into 1 over 2x into 2 equal to 20, and that's equal to 5 over 4x square. 1 plus 1 over 4 is 5 over 4x square minus 8x plus 16 plus 4 and minus 2x minus 20 equal to 0. We get 5 over 4 x square minus 10x minus plus 20 minus 20 will be cancelled equal to 0, and therefore we can write it as x into 5 over 4x minus 10 equal to 0, x equal to 0, 5 over 4x equal to 10, 5x equal to 40, x equal to 8. When x equal to 0, then y will be equal to 1 over 2x plus 1, y equal to 1 over 2x plus 1. We write it as y over 1 over 2 into 0 plus 1, that's equal to 1. And same here is y equal to 1 over 2x plus 1. Then y will be equal to 1 over 2 multiplied by 8 plus 1, that's equal to 5. Now the coordinates of this 0, 1 and 8, 5. Now equation of tangent, the passing through point 0, 1 will be equal to y minus 1 equal to m into x minus 0, and equation of tangent through 8, 5, that's equal to y minus 5 equal to m into x minus 8. Now the gradient of this tangent, you see here, the gradient of the QP is minus 2, and these tangent lines T1 and T2 is parallel to QP. Therefore, the gradient of tangent will be minus 2. This is the equation of tangent QP, and the gradient and minus 2, T1 and T2 are parallel to this normal line QP, and the gradient of this normal is minus 2. We put the value here minus 2, we get y minus 1 equal to minus 2x, and that's equal to minus 2x plus 1. And same here is y minus 5 equal to minus 2 into x minus 8, and that's equal to y minus 5 equal to minus 2x plus 16, and y equal to minus 2x plus 21, and these are the two equations of tangent. Question 11, the equation of the curve is y equal to 4k into square root of 4x plus 1 minus x plus 4, x plus 5. Now we write it as y equal to k 4x plus k into 4x plus 1. We take the derivative on both sides. Now dy over dx will be equal to d over dx of k into 4x plus 1 power 1 over 2 minus x plus 5. Now we take the derivative. The derivative of first expression 4x plus 1, we write it as k is written as it is. Now the derivative of this 1 over 2 into 4x plus 1 power 1 over 2 minus 1, and we take the derivative of this base, and the derivative of this base of 4x is 4 into 1 plus 0 into derivative of x is minus 1, derivative of 5 is 0. Now we write it here as k into 1 over 2 into 4x plus 1 power 1 over 2, and this power is minus 1 over 2. We shift the value from numerator to denominator, the power become positive, into 4 minus 1. Now 2 times 2 is 4. We can write it as 2k over 4x plus 1 power 1 over 2 minus 1 dy over dx. This is the answer. In the next part, you see here find the x-coordinate of the stationary points in terms of k. Now for the stationary points, the dy over dx of the curve will be 0, because when the dy over dx equal to 0 means the gradient of tangent at stationary points. Now dy over dx, we take the 0, we write here is 2k over 4x plus 1 power 1 over 2 minus 1 equal to 0. 2k over 4x plus 1 power 1 over 2 equal to 1. Now 2k will be equal to 4x plus 1 power 1 over 2. We take square on both sides, 2k and the square here. Now we get 4x plus 1 equal to 4k square. Therefore, 4x equal to 4k square minus 1, and x equal to 4k square minus 1 over 4, and this is the answer. Part C, k is equal to 10.5. Find the equation of the normal to the curve at point where the tangent to the curve makes an angle tan inverse 2 with the positive x-axis. Now you see here, this is the curve, and this is suppose that the tangent line, this tangent line makes an angle theta with the x-axis. Now theta equal to tan inverse 2. Now tan theta will be equal to 2. You know dy over dx will be equal to gradient of tangent, and gradient of tangent equal to tan theta, and therefore dy over dx equal to 2. And using this value, we can find the value of x by using this equation dy over dx equal to 2k over 4x plus 1 power 1 over 2 minus 1, and the value of k is 10.5, and dy over dx is 2, and that's 4x plus 1 power 1 over 2 minus 1, and this value of x will be the point where the tangent to the curve passes. And to find this value, we simplify this equation. That's equal to 21 over 4x plus 1 power 1 over 2 minus 1, shift from left to right to left side, that become 3. Now 3 into 4x plus 1 power 1 over 2 equal to 21. Then 4x plus 1 power 1 over 2 equal to 21 over 3. That's equal to 7. And we take the square on both sides. We get 4x plus 1 power 1 over 2 whole square and 7 square. Now that's value equal to 4x plus 1 equal to 49. Therefore 4x equal to 48, x equal to 12. Now to find the value of y, we put the value in this equation. Y equal to k into square root of 4x plus 1 minus 4x plus 1 minus 5. This is the equation of the curve, minus x plus 5. Now we put the value to find value of y, that k is equal to 10.5, x is 12 plus 1 minus 12 plus 5, and this value 10.5 into 12 times 4 is 48 plus 1 is 49, minus 12 plus 5 is minus 7, and that's value equal to 10.5 into 7, and that's value equal to 73.5 minus 7. This value is equal to 66.5, and this is the point. X is 12 and y is 66.5. We have to find the equation of line to the normal this point. We have to find the equation of the normal to this point. Now to find the equation of the normal, that will be equal to y minus y1 equal to m into x minus x1. Now y1 is 66.5, m is written as it is, x minus 12. Now the gradient of tangent is tangent, we write here is 2, gradient of tangent 2. Therefore the gradient of normal will be minus 1 over 2. Now we put the value in this equation, y minus 66.5 equal to minus 1 over 2 into x minus 12. And we can write it minus 1 over 2x plus 6, y minus 66.5. And that will be equal to y equal to minus 1 over 2x plus 6 plus 66.5, and that's equal to minus 1 over 2x plus 72.5. This is the equation of the normal we have to find. This is the answer.